Okay, so I want to talk about, to finish a point I was making about this carbon dioxide. So we had said we've been talking about how carbon dioxide it's probably from coal. It's definitely increasing in the atmosphere, and we're seeing global warming. Now the question that comes up would be, with all of that, does that really mean that carbon dioxide is responsible for the rise in temperature? Now, going back 400,000 years, you can, looking at CO2 and the fossil record, so they can look at the atmosphere and they can and find out what the atmosphere was like in these ice cores, and then they can look at independent then they can independently look at this using fossil records to predict the temperature of the world in the various locations. And so what they found is they generate these temperature and CO2 maps independently, and then they lay them over the top of each other and they say, well, let's see how well the temperature, our predictions of what the temperature was, along with our measurements of what the CO2 levels were, let's see how well they agree. And in your book, it's figure 423, and I'm not going to try and draw it. Let's see if I can show this. We have a red line and we have a blue line. One of those lines is CO2 level and the other line is temperature, and you can see there is amazing agreement between the two. Okay, so enough on that. We had this question, we had this thing, I'm gonna look at my notes to make sure I say this correctly. We have an idea of something called radioactive forcings. And so, and this is all part of computer modeling, trying to figure out what forces are might be responsible for climate change. And so one of them has to do with solar irradiance. And over time, and usually when people are criticizing and saying that climate change isn't real, they'll say, well, that's because of wobble in the tilt on the Earth, and so that's what's really responsible here. Well, so when computers model and test this, what they find is that the orbital variations, this flip-flop that people are making reference to, the shift in the angle of the tilt of the Earth, it's a much longer scale. It's a huge geologic time frame, and we're talking about temperature changes that are occurring now very rapidly. And so in terms of what might be responsible for this, this has a very low likelihood because the variations are much larger time frame. The next possible source for temperature rise would be greenhouse gases, and it was found that this is the most dominant force in these computer models, and it was shown to be 30 times greater than the solar irradiance as a possible idea behind it. There's another idea. There's another question. It's called land use changes. And there's something called albedo. And albedo is how reflective is the Earth's surface. And we had said you have this infrared radiation coming down and hitting the ground. And if the ground is black, it'll be absorbed. And if it's light colored, it can be reflected. And it ends up that albedo is increasing. So, and that means the land is more reflective. So the land is absorbing less infrared radiation than before. And now, why is this? I don't want to leave it go bust through this really fast, but we have global deforestation, right? So we're losing, and we know we're losing forest to cropland. And it ends up cropland is more reflective. And so when we look at global scale changes in the surface of the earth, what we find is that we increase albedo. So that means it's reflecting more of the heat away from the earth. So it can't be responsible for global climate change, unless we were cooling, and we're not seeing that. The other thing that, and it's admittedly a difficult thing to get a handle on, it's aerosols. These are small particles that are in the atmosphere, suspended in the atmosphere, and this is the least well understood. But anyway, so they're still trying to figure that part out, and some of them, depending on their size, they're either reflective or absorptive. So anyway, they take all of these factors that they've studied and they put them into a computer model, and they can come up with a prediction. Now the question would be, well, how accurate is that prediction? And there's an easy way to test that. There's an easy way to test that. We know all of this stuff from the last 50 years or so. So what they do is they say, we've got this computer model we think represents all of the factors that will determine, global climate change. And so what they do is they punch in all the factors from the known period of time and make their predictions that way. And they say, well, let's see how well this works for predicting what we know happened. And what they found is that they got perfectly accurate predictions. And in addition to that, when they try to remove greenhouse gases from the prediction, nothing works. It doesn't work at all. They have to be included. So again, we're building up a very strong case for greenhouse gases being the culprit for global warming, global climate change. Okay, stop right there.